Okay, good morning, grade 12 STEM. So our lesson for today is all about differentiating accuracy and precision. So before we start with this lesson, how do you define accuracy and precision? How are they different with each other? Yes, we all know that these words are basically similar, but in physics, uh, these words have different definition. So let's start. So after finishing this class or this lesson, you are going to learn the following learning objectives. Okay? So first is you're going to define accuracy and precision. Second, identify when to use accuracy and precision. Third, calculate percent error and percent difference. And lastly, recognize the effect of instrument on accuracy and precision. So let's begin. So in everyday life, we use the words precise and accurate interchangeably. How about in physics? Do you think it is right to use these words interchangeably? So what do you think? So as you can see in the picture, there are persons who are trying to play or who are playing games, right? So the other person tells, "Whoa, bullseye, very nice." But the other person said, "Nice, you hit it accurately." So what do you think being the player? What do you think is the difference between the two? So let's proceed. So in physics, accuracy and precision are different. Accuracy pertains to the closeness of the measured value to the true or standard value. So when we say accuracy, so mas malapit siya sa totoong value. Halimbawa, mas malapit siya sa bullseye kung pinag-uusapan natin dito is yung dartboard. Okay? Or yung dart game. So, kapag accurate, mas malapit yung dart sa or mas malapit mong matamaan yung bullseye. Okay? What about precision? So when we say precision, it pertains to the closeness between repeated measurements under the same condition, and it may also pertain to the fineness of the measurement. So nandito na mismo na yung kanyang definition. It pertains to the closeness between repeated measurement. So what do you think repeated measurement? So there are different repeated measurement. So halimbawa, ikaw nag-player, paulit-ulit mong tinamaan yung board. So, it is a repeated measurement. Yung gusto mo kasi tamaan yung bullseye. So, meaning to say, you have a repeated measurement. But, it pertains to the closeness, sabi niya. So, parang magkakasama yung mga repeated measurement na yon in a particular uh, in a particular aspect, parang ganon. Okay? So, when we say accuracy pertains to the closeness of measured value. So when we say precision, closeness between repeated measurements. So take note of that. So the arrows were thrown accurately since arrows were very close to the bullseye, which is the standard. So basically, our standard here in playing the dart board is that the bullseye. So, kapag natamaan mo yung bullseye, so, ang ibig sabihin nun, you are accurate. Tama ka, okay? So, consider that you hit the dartboard 5 times just as shown in the picture. So, halimbawa, paulit-ulit mong tinamaan yung dartboard. And then, the arrows were also thrown precisely because they were clustering in one place. So, ibig sabihin, they are group, mas malapit sila sa isa't isa. So, that is precise. So, balik tayo ngayon sa repeated measurement na sinasabi. So, when we say precision, it pertains to the closeness between repeated measurement. So, when we say accuracy, closeness of the measured value to the true value or standard value. So that is their difference rather. So to fully understand the difference between the two, the illustration has already been drawn. Okay, so only a good measurement can be both precise and accurate. There are situations where the measurement is neither precise nor accurate, precise but not accurate, pero di namang accurate but not precise. So, try this. How were the arrows thrown on the dartboard? So, can you see in the figure A or sa dartboard A na very close yung mga arrows na yon? So, ano nga ba yung masasabi natin kapag very close yung mga arrows? Yung pag hindi siya nakatama sa bullseye but yung mga thrown arrows or yung mga tinamaan nito is parang magkakalapit sila. Next, see the illustration letter B. So, the illustration there is natamaan mo mismo. Isa mismo ang natamaan ng isang arrow yung bullseye. Ngayon, see the different since meron tayong 6 na arrows doon. So, ngayon magkakalapit naman yung mga arrows sa bawat isa. So, how about yung letter C? So, yung letter C, yung mga arrows doon, they are scattered from one place to another. So, we have seen from the previous illustration that the arrows were thrown precisely and accurately. However, it doesn't happen at all times. Let us consider the dartboards and how were the arrows thrown in the dartboard. So, let's check. So, here is now the illustration of it. Okay? So, in letter A, it has high precision and low accuracy. So, precise yung pagkasabi natin or we have we have high precision kasi nga yung mga standard yung mga measurement mo yung mga repeated measurement mo which is the arrows are close to each other, okay, but it has low accuracy kasi malayo siya sa standard value, okay. So the arrows are clustering in one place but are far from the bullseye. So that's it. So, sa letter B naman, it has high precision. Bakit high precision? Sorry, it has low precision and high accuracy. So, meaning to say, sa low precision na yan, yung mga repeated measurement na ginawa mo ay medyo magkakahiwalay. Magkakaiba yung tinamaan nito. Whereas, natamaan mo naman yung standard value. Or yung natamaan mo yung bullseye which is the standard value. So, you have accuracy. Okay? Next, how about the letter C? Neither precise nor accurate. So, the arrows are neither close to one another nor to the bullseye. So, that's it. They are neither precise nor accurate. So, to verify the value of the acceleration due to gravity, the grade 12 students conducted an experiment. Here are the results of the experiment of one group. Are the results precise? Are the results accurate? So here is now the standard, the table 1 that shows the experimental value of the acceleration due to gravity. Okay, so we have 5 trials. So, the first trial has 10 meter per second square followed by 9.7 meter per second square. But the question is, are the result precise and are the result accurate? So, what do you think? So, basically, the standard value or the acceleration value, the standard value is the acceleration due to gravity which is the 9.8 meter per second square. So, based on the presented table, did we met or did we get the 9.8 meter per second square? So, aside from playing the dartboard, we can also observe accuracy and precision in the results of the experiment. So, that's it. So, the question is, are the results precise? And are the results accurate? Okay, malalaman natin yan. Okay, next. The percent error indicates how near the measured value to the standard value. So, meaning to say, we have to consider the percent errors. So, the formula in getting the percent error is the following, is presented now. So, percent error is equal to the measured value minus the standard value divided by the standard value multiplied to 100. So the percent error indicates how near is the measured value to the standard value. So basically, percent error is pertaining kung gaano kalapit yung resulta ng trials sa standard value. As the percent error increases, the accuracy of the measurement decreases. So that's it. How do you say so that if the percent error increases, the accuracy of the measurement decreases? Kasi habang papalayo yung mga value or kapag pataas ng pataas yung percent error natin, meaning to say, yung accuracy ng measurement is nawawala na. Parang lumalayo na siya sa standard value. Okay? So, in most cases, measurements with percent error lower than 10% is considered to have high accuracy. So, basically, if the percent error is lower than 10%, it has high accuracy. So take note of that. If the percent error is lower than 10%, it has high accuracy. So ang ibig sabihin lang nito, habang papalaki yung percent error, pababa naman ng pababa yung accuracy. Okay? So next. So we have also the percent difference. So when we say percent difference is equal to percent difference indicates how near is one measured value to the mean of the entire measured value. So how do we get the mean? How to get the mean? So basically, balik tayo dito. Let's just add all the values, okay, the given values, and then after getting the sum of it, you can just divide it by 5 to get the mean. Okay, now so the formula in getting the percent difference is that we have the but before that, let's see what is percent difference. So percent difference indicates how near is one measured value to the mean of the entire measured values. As the percent difference increases, precision decreases. So what is the difference between the two? As the percent difference increases, the precision decreases. So meaning to say, in most cases, mas papalapit siya sa accuracy. Okay? So, measurement with percent difference lower than 10% is considered to have high precision. So, meaning to say, dun kanina sa ating percent error, kapag lower than 10% ang iyong kapag lower than 10% ang iyong percent error, meaning to say you have high accuracy. Dito naman sa ating percent difference, if you have lower than 10%, you have high precision. Meaning to say, malayo ka na sa maaari, okay? Maaring malapit ka sa accuracy, but you have a high precision. So, for you to understand more regarding this, we have this solution. So trial 1, percent error is equal to 10, which is the given value, minus 9.8, which is the standard value, times 100. So, we did get 2%. So, meaning to say, percent error is 2%. Kapag ka 2% yung percent error, is it precise or is it accurate? Does it have a high precision or does it have a low precision, or mataas ba yung accuracy or mababa ba yung accuracy? So, take note na kapag mababa yung percent error, which is the 2%, mataas yung accuracy level ng inyong experiment. So, halimbawa nito is we have 2%. So, the given values here is 2%. So, kapag ang naging, like for example, the given here is the experimental value of the acceleration due to the gravity in trial 1 is 10% minus the standard value which is the 9.8. So, malapit lang naman kasi ang 9.8, ang 10 sa 9.8 which is your standard value. So, meaning to say, the percent error is 2. So, mababa siya. So, mataas yung accuracy level nito. So, what about in percent dito sa trial 2? Okay. See the difference. So, alin ba ang mas malapit sa 9.8? Yung 10 ba na first trial or yung 9.7? Okay, let's see. Percent error is equal to 9.8 minus 9.7 minus 9.8 divided by 9.8 multiplied to 100. So, we got 0.1 divided by 9.8. So, the percent error is equivalent now to 1%. And take note na kapag mas mababa kapag mas mababa yung percent error, it has high accuracy. So, take note, tignan nyo dito sa ating table. Okay? So, yung ating acceleration due to gravity is 9.8, right? So, ang 9.7 ay malapit sa 9.8. So, parang ang percent error lang niya is 1%. So, mas malapit siya sa accuracy. Okay? So, take note class dito na if the percent error is lower than 10%, it has high accuracy. Okay? So, let's proceed. So, what about the percent difference? So, the percent difference is equal to 10, which is the given value, minus 9.54, which is the mean. Okay? Yun yung mean. Okay? Divided by 9.54, which is the mean, times 100. So, we did get 5%. So, take note that 5% is also medyo it's considered as accurate pa rin. So, medyo mas accurate pa rin siya. So, take note na ang 10 is malapit pa rin siya sa 9.8. Now, what about the percent difference in trial 2? So, mas malapit ang 9.7 sa 9.8. But, let's see. So, 9.7 minus the 9.54 divided by 9.54 times 100 is equal to 0.16 divided by 9.54 times 100. So, we did get 2%. Meaning to say, mas accurate na naman yung trial 2. So, paano kapag ang ating trial 3 ang gagamitin? So, basically, kapag percent difference ang gagamitin natin, 9.8 minus 9.54 divided by 9.54 times 100 is equal to what? So, answer that later on. So, let's try this, okay? Calculate the percent error and the percent difference of trials 3, 4, and 5. So, tapos na tayong nag-identify ng percent error at percent difference sa trial 1 and 2. So, uh, take note of our formula. So, balik tayo sa ating formula. Okay? For you to understand the formula of percent error is equal to measured value or the given value minus the standard value divided by the standard value multiplied to 100. Next, percent difference is equal to the given value or the initial value or the measured value minus the mean of the given values minus divided by the mean times 100. So let's do this. I'll give you time to finish that. So for 9.8, 9.4 and 8.8, you should finish that, and I will message me if you already finished that para at least uh, mamayang dapat natapos nyo yan mamayang 8:20. Okay? 8:20 dapat natapos ni dapat 9 o'clock tapos nyo na. Okay? 9 o'clock tapos nyo na yung number 3, 4, 5 trial. So, ano kaya? The question is, yung fifth trial natin, what do you think? Okay? Is it high accuracy ba siya? Accurate ba yung kanya? How about number 4? Is it high accuracy? Does it have high accuracy? How about yung trial number 3? So I'm going to check that later on. So now you can screen capture that, and I'll be waiting for your answer at exactly 9 o'clock today. Okay? Next. The accuracy and precision, okay, effect of instrument in measurement. So, what do you think? Which of these two weighing scale do you think will give the accurate mass of an object? So, meron tayong 2 kiluhan dito. Okay. Now, the figure 3 is weighing scale which can measure at different level of accuracy. So, what do you think? The first weighing scale A will give an accurate mass of object because the pointer is at exactly 0 kilogram initially. So, basically, the standard value for the kilogram is 0. So, syempre, ano ba nga bang pipiliin mo kapag pupunta ka sa palengke at mamimili? Syempre, yung nakatapat sa 0 because it is the standard value, okay? So, kapag nakita mong medyo tagilid yung kilohan, syempre, medyo magkakaroon ka na ng agam-agam tungkol dito. Kaya, ang gagawin mo, or ang ginagawa ng iba is medyo sinusobrahan nila yung value or ginagawa nilang accurate or nakatapat talaga sa 0 yung value. So, next. From the definition given earlier, precision may also pertain to the fineness of the measurement. Now, the question is, which of the two weighing scale do you think will give a more precise measurement? So, yung kanina, yes, sa ating letter A, which is the, what do you call this? The standard weighing scale, meron tayong standard and a digital weighing scale. So we have a standard and digital weighing scale. From that two object or from that two measuring instrument, which of these two are more precise? Okay, more precise. So I'll give you 5 seconds to answer. A or B? 5, 4, 3, 2, 1. So the correct answer is letter B. Okay, so that's it. So the digital weighing scale can give a more precise result because it can display the measurement of the hundreds of kilogram. That's it. Kasi meron siyang repeated values. Okay? Meron siyang repeated parang measurement. Dinidisplay niya pa rin yung halimbawa we have 1 kilogram 1.8. So yung 8 doon is halimbawa it's uh, a mass, okay? Or what do you call this? Um, evalue also. Parang it is a repeated measurement. So take note or remember, accuracy pertains to the closeness of the measured value to the true or standard value. Next, precision pertains to the closeness between repeated measurement under the same condition, and it may also pertain to the fineness of the measurement. So, I hope naging maliwanag sa inyo yung ating lesson today. So, uh, if you have question, don't hesitate to ask me through Messenger. Okay? That would be all. Thank you very much.